Number 1 says Nella and Lydia are hiking 15 miles today. After every half mile, 0.5 tenths of a mile, they will stop and rest. How many times will they rest during the hike? So we can look at this one of two ways. We can first think to ourselves, okay, I've already made hashtags of, or hash marks of 15 miles. If they're stopping every half a mile, that means they're stopping here, 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 and we could count those up individually. We could say that we're dividing the 15 miles by 0.5. And we know that when we divide by a decimal, we're going to move that over 1, which means this has a decimal here. We need to move that over 1, which means we need to add a 0. So I'm going to rewrite the problem. It looks like this now after we've moved the decimal place over. And now it's just a basic math fact. 5 doesn't go into 1. It goes into 15 3 times. Bring down my 0. It goes into 0 0 times. They stopped 30 times. A cookie cutter shark is 0.4 meter long and a thrasher shark is 6 meters long. How many times as long as the cookie cutter shark is the thresher shark? So it's saying how many times, this is this part here, as long as the cookie cutter shark is the thresher shark. The thresher shark is longer. Well, if you think about an easy problem like 2 times what equals 6, that's the same thing as saying 6 divided by 2 equals what? So we know that this is a division problem, so we're going to take 6 and we're going to divide by 0.4. And again, when we move our decimal point over, we're going to move this decimal point over. Remember, every number has a decimal point at the end, so it's just unseen. We're going to move that over and we're going to add a 0. Again, I'm going to rewrite the problem now. 4 goes into 6 once. Bring down my 0. 4 goes into 20 5 times. So it is 15 times longer. At a large wedding, the cakes were cut into hundredths, so each piece was 1/100th of a whole cake. If there were 12 cakes, how many pieces were there? So they took 12 cakes and they divided them into hundredths. We need to take and move our decimal point over 1 2 spots. So here, there's our decimal point. We have to move it over 1 2 spots. So we're going to add 2 zeros in to those. And now we have 1 goes into 1200, which this should be a mental math fact, but if it's not, we could go 1 goes into 1, 1 goes into 2, 1 goes into 0, 1 goes into 0. There were 1200 pieces of cake. Number 4 says a millimeter is 1/1000th of a meter. How many millimeters are there in 7 meters? So if I think back to my chart way back from the beginning of the year of meter, decimeter, centimeter, and millimeter, and I said that if I have 1 meter, I have 10 decimeters, I have 100 centimeters, and I have 1,000 millimeters, because we're just adding on 10, or in this case, taking away 10, or dividing by 10. So if I have 7, if I change this number to a 7, 7, 7, 7, I have 7,000 millimeters in 7 meters. Paco saves 75 cents each day for a new bicycle helmet. He has saved $36. For how many days has Paco been saving? So that means what we're doing is we're taking the $36 and we're dividing it by 75 cents. Here again, we need to move over our decimal point 2. So we move this decimal point over 1, 2. So we have, I'm going to rewrite it so it's nice and neat, 3,675. And this is just going back to a couple of lessons ago where we're just going to divide out. It doesn't go into 3 and it doesn't go into 36. And 75 is right in the middle, so we have to kind of be careful here. 8 goes into 36. I'm going to take a chance and I'm going to go up to 5 just because 75 is in the middle. 5 times 5 is 25. 5 times 7 is 35 plus 2 is 37. Okay, that did not work. I should not have taken the chance, I guess. So we're going to go down to 4. 4 times 5 is 20. 4 times 7 is 28, 29, 30. Subtract and I get 6. Okay, now look here. If 4 times 75 is 300, then if I double the 4 to 8, then 8 times 5 is going to be 600. 8 times 5, 75. 8 times 5 is 40. 8 times 7 is 56, 60. And we have 48 days. Now, if you had done something incorrectly and you'd accidentally multiplied, your answer would not have made any sense. Now we're just getting into the practice of moving the decimal point. We can't have a decimal point in the divisor, so we're going to move it to make it a whole number. And if we move that 1, then we have to move this 1. Remember, this is saying the same thing as I'm multiplying this by 10, so I need to multiply this by 10. If I multiply 0.9 by 10, I get 9. If I multiply 63 by 10, I get 630. And then it's just a mental math fact of 9 goes into 63 and 9 goes into 0, and there's your answer. So again, you can think of this as being, all right, I need to multiply 8 hundredths by 100 in order to move it over 2 spots. So I need to multiply 72 by 100 and then move this decimal over 2 spots or add 2 zeros, however you want to say it, whichever way is easier for you. Then if I rewrite it to make sure, and remember I have the 2 zeros added on, I have 8 doesn't go into 7, it goes into 72 9 times, and then I add my other 2 zeros. This time I'm multiplying by 1,000 because it's in the tenths, hundredths, thousandths, which means I need to multiply this by 1,000, or I can think of it as going over 1, 2, 3 spots. It almost looks like a smiley face. And 1, 2, 3 spots. And then I think 7, and then 42, and then I have to add in 1, 2, 3 zeros. 1, 2, 3. I divide. 7 goes into 42 6 times, and that is even, so I can just add the other zeros on. Here I'm multiplying the 6 by 10, so I multiply this by 10, or I can think of it as I'm moving this over 1 place to the right, so I need to move this over 1 place to the right and add that 0 in. So I have 6 goes into 4,200. 6 doesn't go into 4, but it goes into 42 7 times. 7 times 6 is 42, and then I add those 2 zeros on. Here again, I multiply this by 10, so I need to multiply this by 10. If I multiply this by 10, it just moves a decimal over. If I multiply this by 10, it adds a 0. So I have 3720 divided by 4. 4 goes into 37 9 times. 9 times 4 is 36. Bring down my 2. 4 goes into 12 3 times. 3 times 4 is 12. Bring down my 0. 4 goes into 0 0 times. I'm going to jump ahead to number 13 to give you a chance to do a couple on your own. Here again, I can either think I'm multiplying this by 100, so I multiply this by 100. When I multiply this by 100, it moves the decimal point over twice. When I multiply this by 100, I get 2 zeros. So I have 71 goes into 113600. I'm going to round this to 70. 71 doesn't go into 1, it doesn't go into 11, and then I think, okay, 7 goes into 11 one time. 1 times 71 is 71. 42 is less than 71, so I can bring down my next number. 7 goes into 42 6 times. 6 times 1 is 6. 6 times 7 is 42. And remember, you can always just rewrite this over there, and then you're going to get the same answer. When I subtract, I get 0. I bring down my 0. 71 goes into 0 0 times. 71 goes into 0 0 times. On to the remembering side, we're trying to find equivalent fractions again, and actually we're trying to find not equivalent. If I take 4/10 and I divide it by 2, I get 2/5, so that's equivalent. If I just take these zeros out, that gets to be 2/5. If I take 6/20 and they're both even, so I divide them by 2, I get 3/10. well, I think this one is going to work, but I want to check. 10/25, I'm going to divide both of these by 5, and I get 2/5. That doesn't, so I was right. That is the one that's not equivalent to 2/5. So I'm going to do the same thing here, except this time I'm going to go ahead and simplify this. I know that 3 goes into both 3 and 12. 3 times 3 is 1. 12 times 3 is 4. So right off the bat, I know that doesn't work. 6/24, the biggest number that will go into both 6 and 24 is 6. So I divide both by 6 and I get 1/4. That one doesn't work. I'm going to take 12/48, and I know by my 12, 24, 36, 48 that 12 goes into 48. So I'm going to divide both of these by 12, and I get 1/4. So that one doesn't work. So let's just check 9/30 to be safe. I know that 3 is the biggest number that will go into both of them. 9 divided by 3 is 3. 30 divided by 3 is 10, so this one doesn't work. I'm just going to do a couple of these because I just want to remind you the two different ways you can do this. I can either say 5 goes into 18 3 times, which is 15, and then 16, 17, 18, with 3 left over, and my denominator stays the same. Or if that's too hard, you can actually make it a division problem where 4 goes into 25 6 times. And then remember, we go around the clock, so we start with 6 and 1/4. So we have 6 and 1/4. So here, 10 goes into 66 6 times with 6 left over, and my denominator stays the same. But then I'm going to have to take 6/10, and they're both even, so I'm going to divide them by 2, and I'll get 3/5. So this really should be 6 and 3/5. And I'll let you do the rest of those. Number 9 is telling you that each edge of this is 6 inches. So it's asking the area. Well, the area, remember, is length times width. So that's 6 times 6. So you're going to get 36 inches squared. The volume is length times width times height. Well, the length is 6, the width is 6, and the height is 6. So we have 6 times 6, which is 36. And then we need to multiply that by 6. So I'm going to do it over here in the corner. 18, 19, 20, 21. So I have 216 inches cubed. Number 11 is a little bit trickier, but you have to remember you're talking about a cube. So every side is the same. So I have to figure out if each of these, the length, the width, and the height are all the same, what equals 125. So let's just start with 3. 3 times 3 times 3 is 9 times 3. That's 27. That's pretty far off, so I'm going to go ahead and jump up. Oopsie. I'm going to jump up to 5 and see if that works. I have 5 times 5 times 5. 5 times 5 is 25. And if I think about having 5 quarters, that's $1.25. So the length of each side is 5 centimeters. Now that I know that this is 5 centimeters, my area is easy because I just need to take my length times my width, which is 5 times 5, which gets me 25 centimeters squared. And for the last one here, I'm just going to underline your, oopsie daisy, sorry about that, your clue here, how much higher and combined heights, so you'll know what operation to use. And then I'm just going to do the last one as a reminder. You can do the lattice method if you want, or the area model. I'm just going to do it with 4 times 6 is 24. 6 times 8 is 48, 49, 50. 6 times 1 is 6, plus 5 is 11. I'm going to put in my 0 as a placeholder because I'm done with that 6. 5 times 4 is 20. 5 times 8 is 40, plus 2 is 2. And then we have 9. We're going to add those together and get 10,304.